Hello everyone. Thanks for coming. So my name is July. I'm from IT University. I'm working in computer science. I'm on the software engineering side of the story. So I'm going to talk about the tool development part in our project. So before yesterday, I got this so-called breaking news. Actually, it's a news about Honda who recalls some of its vehicles because of software problems. Probably you have already heard this kind of story over and over again last decades. Actually, software reliability is an issue. It is a problem that is spreading in the digital world. So this is what I'm going to talk about, software reliability. So now coming to our ROS part. This is an important goal. We want to make ROS reliable or more reliable. We all know that ROS is everywhere now whenever we talk about robotics. To some extent, we are in a vulnerable position because we depend on it. We want it to be reliable. So since 2017, we, the IT university researchers in Copenhagen, we have been working on how to test ROS components automatically. To test is to make a software fail. To test it automatically is to make it fail automatically. So we need to deal with the challenges from the ROS-specific challenges. And we want to reuse some existing tools from the academic world. And today I'm also going to talk about, I'm going to show a demonstration of our ongoing work. So these are the first challenges that I want to talk about. Very important, the lack of specification. So here is the total SIM package. It's a screenshot I got. It's a bug that I detected, and then I submitted a pull request. The pull request was accepted. The expected behavior of this turtle is to draw squares. The bug is the turtle spins after 1/3 of the square. So this turtle does not going to crash your system. The bug is going to go undetected. In fact, this kind of bugs, they occur quite often. They are silent bugs. They do not manifest themselves because there is no specification. There is no way for automated testing tool to know if a bug happens or not. So it's very difficult to do automated testing without knowing what is right and what is wrong. Specification is the first thing that we need. The second thing we need is good test driver. So a test driver is something that launches ROS components, very simply. A good test driver is something that fails your ROS components. How can we automatically have these good test drivers? That's a big challenge. So our solution is to rely on existing techniques from academia. The idea is that if you don't have it, you try to get it. For the challenge number 1, we don't have specification. We want to use sanitizer from the academia. It's existed, it has already been there, it's mature stuff. If you don't have good test drivers, you try to use fuzzing. Again, it has been there, it's mature stuff. So I'm going to briefly introduce these two guys. So what is a sanitizer? For example, you have a line of code x equals to y divided by z. A sanitizer is something that introduces an assertion here. Z is not equal to 0 because you don't want to have division by 0 here. A sanitizer is something that has already built in in our compiler, like GCC or clan. So it's like you just use GCC dash. I want to use a sanitizer. You get the sanitizer. You get the assertion injected in your code. Sanitizer can do more than this. It injects automatically other assertions, like array index out of bound, and many others about your memories, for example. Now, about fuzzing, it's another very interesting stuff that we ROS folks should consider using. It all started in 1987 from University of Wisconsin. What they did, they used some pure random data to feed the Unix command line. What they have found is that 1/4 of the Unix utilities that have been tested crashed. So this is quite phenomenal. It was very, very surprising at that moment. So pure random testing worked very well. Now fuzzing is smart random testing. It's random testing plus street smarts. So the diagram here is what the high level part of the fuzzing stuff. You have a software treated as a black box. You feed random inputs into the software. You get the output. Fuzzing is something that observes the output and gives the feedback to your random input generator to help you to get more sensible, relevant random inputs to your software to trigger more crashes. Again, this is something that has existed there. We do not need to reinvent the wheel. We want to reuse it. Fuzzing has been used to detect numerous bugs in open source projects. Microsoft, Google, and many other big companies, they use fuzzing daily. So it's something I suggest the ROS folks to consider using. So now the high-level approach of our tool should be simple here, at the high level at least. You have the ROS package. You inject specification into with the so-called sanitizer. And what you get is what I call here specification carrying ROS. ROS that carries those assertions. And now you use fuzzing to crash your spec carrying ROS packages. So you reuse two components that have existed already. So now a quick demonstration from our ongoing work. So let me see if it works. Okay, I'll explain shortly later. So what do you, let me finish this one. Okay, what you see is actually the turtle sim package, the hello world package for ROS. You have a turtle that is supposed to just draw a square, but the testing tool is going to feed random data for the turtle. So the turtle is supposed to go wildly in all directions. Because we have a very short time out here, so you only see the turtle at the beginning of his life. The turtle is changing. It's supposed to go in all directions. So ideally, this is going to find a bug, but we have not yet found it. We believe it's just a question of time. But this is ongoing work. It's the beginning of something we believe very, very interesting. Now, conclusion. So we want to build reliable ROS components. What we do is we try to reuse existing solutions from academia. One is sanitizer. Another one is the fuzzing technology. Thank you. That's all what I want to say.